Okay, so an ellipse. First of all, let's give the definition of an ellipse. We've done definitions of both the parabola and the circle, so we might as well do the definition of an ellipse as well. And it's a set of all points as well, just like we did before. It's the set of all points P such that the sum of the distances from two fixed points these two fixed points are called the foci or the foci. Okay, so it's the set of all points P such that the sum of the distances from two fixed points called the foci is a given constant. Okay, so that's the definition, and I want to show you what I mean by that. Yeah, I've got it a little bit too long here, but that's all right. Good enough. Okay, does everybody have this down? Okay, so let me show you. So I'm going to have two fixed points. I'm going to have one fixed point right here, and I'm going to have the other fixed point right there. And the sum of the distances from my point P to those 2 points is always going to be this length. Okay? Now to show you that this indeed makes an ellipse, here's what I'm going to do. Hopefully, let's see if this works. All right, we're going to put this right here. Go away, we don't want you. There we go. Oh, it made my point go away. I'll put that point right back there in a second. And we'll put this one up here. Okay. And let me get my point back. Okay, so there are my 2 points. Okay. The sum of the distances is always going to be the length of this string. For example, if I pull it tight, here would be one of my point P's right there. Okay? But if I moved over here, here would be another point P. I took the 2 distances from this point P up to the green dot and then over to the red dot and added them. They would be the same sum as if I took these 2 distances and added them. Now, if I continue all the way around, notice what is happening. It is. Let's see if it'll let me come up here. And there's your ellipse. Okay? You see that? If I take any point on that ellipse, any point like this point P, and if I measure the distance to the red dot and to the green dot, and I add those 2 together, they will always add up to be the same thing. This and this added together will be exactly the same as if I put my point P down here and I did this plus that. It doesn't matter where that point P is. Whenever I add them together, those 2 distances will always add to the same sum. Does that make sense? Yes. This one right here? Okay, so then if I take this distance and I add it to this distance, they will add up to the same thing, this one plus that one. They're always going to add up to the same thing. Okay? Now, what's going to happen, and these 2 points, by the way, are called foci, 2 points that I started with. What would happen if I moved those 2 foci closer together? So let's see. Oh, not when it gets caught on that. It's not going to be more circular. And not when it comes undone. It's not going to be more circular. Let's see if we can retape it. All right. All right, let's try this again. It's a little bit different now because I taped it in a different spot. Oh, gosh. Yeah. All right. For those of you who said it was going to be more circular, you're absolutely right. What would happen if I got those two foci right on top of each other? They would make a circle, and instead of being a focus, it would be a center, okay? So as these two focal points come closer and closer together, your oval gets more and more circular. The further apart they are, the more spread out your ellipse is. Yes? You can think of it that way because a circle is just a special ellipse, okay, where the two foci are right on top of each other. Yep, absolutely. So what I've done here is I've just put up two ellipses, and what I want to do is give you some, just some terminology, and you might want to write this down. Whichever axis is the longer axis, we call that the major axis. So on this picture, the major axis is right here, and on this one, it's the y-axis. Any ideas what the shorter axis is called? Minor. So in this case, the minor axis is the x-axis, but on this one, it's the y-axis. Okay? Now, it turns out that your foci are always on. Any idea which axis they have to be on? The what? The major axis. The foci are always on the major axis. So sometimes it's the x-axis and sometimes it's the y-axis. It just depends on how your ellipse is opening up. Okay? It turns out that we call this point right here, this point has coordinates a comma 0. This one is 0 comma b. Over here, this point is going to be negative a comma 0. And this point has coordinates 0 comma negative b. And that's important for the equation. Here is the general form for the equation of an ellipse. This is the form we like to get it into. X squared over a squared plus y squared over b squared is equal to 1. If you always get it equal to 1, then this is going to work out. You'll have an a squared down here, and if you square root that a, that tells you where your x-intercepts are. If you have it set equal to 1 and you look under the y squared term, this b squared, if you take the square root of that, that'll give you your y-intercepts. Okay? Now, the reason that that's nice is because we're also going to want to be able to find where those focal points are, where your foci are. Guess what I call the distance from the center out to a focus? And it doesn't matter which one because they're equidistant from the center. That distance is called c. Okay, that distance is called c. And we had a little formula for finding c, I guess, when we did the parabola. Remember, we had a was equal to 1 over 4c. Well, we have a little formula here as well. And it actually is for c squared. And c squared is either going to equal a squared minus b squared, or it will equal b squared minus a squared. Any ideas why it could be one or the other? Okay. It can't be negative. So if your ellipse is going this direction, which is bigger, a or b? A, and if a is bigger, then isn't a squared bigger? So in this case, in this first case, if it's kind of stretched horizontally, you'll use a squared minus b squared. But over here, you'll use b squared minus a squared because the b value will be larger. Let's see. These points that are on the major axis, we call our vertices. Vertices are those points on the major axis, those endpoints on the major axis. The endpoints on the minor axis are called covertices. And that's just terminology that you're going to need when you go through and try to work out some of these problems, because they'll tell you vertices or covertices, and you just want to know if they're on the major or the minor axis. All right. So with all of that information, let's see if we can graph a few of these ellipses and do a little bit of work with them. So the first one says this: graph 25x squared plus 9y squared equals 225, and then find the foci. So go ahead and write down that equation. Okay, what did I have the general form of the ellipse looking like on that last slide? It was equal to 1. So I want to get this equal to 1. One way is to subtract a 224, but that isn't really going to be very helpful. What else did that equation have besides equal to 1? It had fractions. How can you get fractions? Yes, divide everything by a 225. And if you do that, you end up with x squared over what? 9 plus y squared over 25 is equal to 1. Now we're going to graph this. And actually, graphing these should really be pretty easy, because you look under the x squared. There's a 9. Do the square root of that, and that tells you how far left and right from center you're going. How far left and right from center should you go? 3. 1, 2, 3, and 1, 2, 3. Your A value is 3. What about your B value? 5. That means from center you're going to go up 5 and down 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And now you can get your ellipse. Okay, excellent. Now, we're supposed to find our foci. Which axis are they on, the x or the y? They're on the y-axis. How do you know? Because it's the longer of the two. Okay, so to find them, I know my equation is c squared, and it's either equal to a squared minus b squared or b squared minus a squared. Yeah, I want to do b squared minus a squared. So c squared is equal to 25 minus 9, which is 16. Therefore, c is 4. Yeah, and if you want, you can put plus or minus 4. That will help remind you to go both in the positive and the negative direction. So, 1, 2, 3, 4. Here's one focal point. It's at 0, 4. And the other one is down here at 0, negative 4. So if you wanted to, you could put that your foci were at 0, plus or minus 4. Any questions on that? Okay, let's look at this one. Write the equation of the ellipse centered at the origin with one vertex at 0, negative 6, and a co-vertex at 3, 0. Next, find the foci. What do you think would be helpful to have first? What? A little picture, right? Sketch pictures, guys. Okay, so you have a vertex at 0, negative 6. If that's a vertex, what else do you know? Okay, 0, 6, because it's centered at the vertex. Okay, the co-vertex at 3, 0. What else do you know? Okay, negative 3, 0. You see your ellipse? Okay. Now, the way that I usually do these is I just set up the general form, and I know it's going to be x squared over something plus y squared over something is equal to 1. How do I get what goes under here? Well, I look at X and Y, and I see, or I'm sorry, I look in the X direction and I see how far I went. How far do you go from center out to either side? 3. What do you have to do with that 3? Square it to get 9. Your A is 3. What's your B value? 36. Your B value is 6, so B squared is 36. Now, how are we going to get our foci? Okay. It's going to be B squared minus A squared again. So C squared is going to be 36 minus 9. So that's 27. So C is plus or minus 3 root 3. Now, is that on the X or the Y axis? The Y. So the coordinates of my foci will be 0, comma, plus or minus 3 root 3. Any questions on how I got the equation or the foci? How'd you do this one? Write the equation of an ellipse with foci at plus or minus 7, 0 and covertices at 0, plus or minus 6. Okay, so let's sketch it. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Can I draw my ellipse with what I have? No, because what don't I know? Do I know which axis is the major axis? Yeah, which one? X, how do I know? The foci are on there, right? And the foci are always on the major axis. But can I draw the ellipse with those 4 points that I have? No, because these are the foci. Where are the foci in relationship to an ellipse? Inside. So I know that my actual vertex points need to be outside of that. How am I going to figure out where they're at? I'm going to backtrack using which formula? Yeah, now, which axis is going to be longer? The X, so which comes first, A or B? A, so C squared is going to have to equal A squared minus B squared. Well, we know what C is. C is 7, so this is going to be 49 equals, I don't know my A, but it's going to be minus B squared, which is 36. Therefore, A squared will equal 49 plus 36, so 85. Now, do I really need to even know what A is? Because I'm just supposed to write the equation. Do I need A in the equation? No, you could find it, but you don't need it. Because your equation just says do X squared over A squared, which is 85, plus Y squared over B squared, which was, and that has to equal 1. And there's your equation. Okay? Any questions on how I did that, working backwards? Okay, then I have one last quick thing that I just want to point out to you. It says write the equation of an ellipse with a width of 4 and a height of 8. So I just want you to be careful because this one isn't too hard. But if it says it has a width of 4, center it at the origin. That would be the easiest way to write the equation. And if it has a width of 4, yeah, just make sure you go right 2 and left 2, not 4. You see? See that the whole width is 4? And from center, how far up and down are you going to go to get a height of 8? Yeah. Okay? And then could you write your equation? It would be A squared over 4 plus B squared over, oh, sorry, X squared and Y squared. Thanks. X squared over 4 plus Y squared over 16 is equal to 1. Okay? So I just wanted to point that out, that height and width don't go too far. All right. On page 571, numbers 2 through 25, the second column, and then I just picked out some random problems here. The reason I said the second column, sometimes there are 3 columns and sometimes there were 4. So just go to the second one from the left.
Wait,